I'm Venkat Vishwanathan, a new assistant professor in the Department of Mechanical Engineering at Carnegie Mellon University. A typical battery consists of three components: an anode, a cathode, and an electrolyte. And one of the key things that's often forgotten is the electrolyte. The electrolyte is the key component that's a major limiting factor for safety. Think of the Boeing fires. It's because of the electrolyte that the Boeing fires caught fire in the first place. And so one of the efforts that we are trying to do is to launch something called an electrolyte genome, where what we would like to do is to sort of accelerate electrolyte discovery on the computer. The idea here is that we have a database of physiochemical properties that you can then query in the very same way you query on Facebook, like you would query, let's say, my friends who went to Carnegie Mellon and live in California. In the same fashion, you can query solvents that have a HOMO level less than a certain number is in the liquid state. And so we believe that this sort of querying is super critical because electrolytes have to satisfy several different criteria, and querying something like this would actually really help experimentalists test out new formulations that would be extremely useful to enable next generation batteries. Today's lifestyle is sort of being afforded because of the enhancement in battery technology. The kind of energy storage devices that we have are powering our smartphones, laptops, and so on. The next obvious sector to really penetrate is the transportation sector. And to enable batteries for electric vehicles, what we need is new stable formulations of electrolytes that sort of can withstand the harsh environments that are needed if we want the more compact and energy-dense batteries. And so I think the impact of the electrolyte genome is that we will hopefully come up with new electrolyte formulations that will enable batteries for electric vehicles. A prototype of the electrolyte genome is already up and running, and you can actually query it. I think what we would like to do and go forward is make a visual querying framework where you can basically draw on a canvas, and then you can basically query exactly what you want, and then the engine will essentially retrieve what you would like. A major part of this electrolyte genome is actually trying to find the descriptors that would be the metric for stability, and I think that is the critical aspect where there are scientific challenges that are involved, and those are the things that we are trying to really push, along with making the database more open and more user-friendly to query. I think that is also another frontier that we are pushing. We hope that through this electrolyte genome, we will test out new and stable electrolyte formulations that will enable the elusive batteries that are essential for addressing the electric vehicle market.